Up until this point, we've been discussing probabilities as though they occur only for one variable on their own. However, probability distributions can represent the probability of multiple random variables simultaneously. So, for example, in terms of notation, the probability that both some variable x is equal to some specific state x and some variable y is equal to some specific state y is given by this notation here, where we have our good old p probability, and it's the probability that this variable x is equal to this particular state x, and this variable y is equal to this particular state y. And we use a comma to separate whatever variables we have in our joint probability distribution. We could, of course, have more than just two. Again, we'd separate by commas to add additional variables in here. As examples, consider that instead of having coin flips be considered as a single variable, you could consider them as separate ones. So this is kind of an easy transition into this idea of a joint probability distribution using probabilities that we've already worked with now quite a while ago in these live lessons. So this first probability, x, that the flip 1 x is equal to this particular state of x, heads, and that our second flip, we can call that y, is equal to some specific state, again, heads. So the probability of both of these being true is equal to 0.25. And we worked through that probability earlier. And then as a second example, again, following on from some kinds of examples that we've been working with earlier in these live lessons, consider that the first probability in our joint probability distribution could be card value. So let's say an ace. And then a second probability could be the card color, which would be red. So there are two cards in a deck of 52 that meet both of these criteria. And because we have an ace of hearts and an ace of diamonds, and so that gives us 2 out of 52 cards in the deck meeting both of these criteria, which simplifies to 1 in 26, or about 0.04. All right, and then a third and final example where we're looking at a kind of situation that we haven't looked at before. So we're looking now for the probability, and I'm using a lowercase p here on purpose because in both of these previous cases, we were talking about a probability mass function and discrete random variables. But here we're talking about a probability density function and a pair of continuous random variables. So the probability of having a person who is 180 to 190 centimeters tall, which is pretty tall for people who are used to using feet, and also has a weight of 20 to 30 kilograms, which is pretty small for those of you who are used to using pounds, the probability of a person meeting both of these criteria is 0. Nice, so straightforward enough. Up next, we're going to build on this concept and talk about marginal probabilities.